Hello, my name is Jung Kim, and I'll present our paper PromptDresser, improving the quality and controllability of virtual try-on via generative texture prompt and prompt-aware mask. So the first motivation, our goal is to enhance text-based controllability in a text-to-image backbone. Prior work such as Stable Python did not use text at all. In contrast, if we do leverage text, the same reference image can yield diverse styles depending on the prompt, as shown in the right figure. However, in virtual try-on, simply labeling a text prompt and applying it introduce two key challenges. As shown in the figure, prompts that richly describe the target image, like in general text-to-image model, tend to repeat information that lies mostly inside the inpainting region, such as much of it is unnecessary, as shown in the red underlines. For example, horse stance is not important, and some pants or face information is already exist in the unmasked region. And also, it can even describe the region we intended to edit. Here, the top clothing. If we want to dress the person in a black dress, it becomes ambiguous how to merge a target descriptive prompt with a reference descriptive prompt. And second challenge is spatial conflict. This is related to the conventional agnostic mask. So the agnostic mask is here, and unlike the training setting where the target person already wears the reference clothing, at inference, the two images can differ. Empirically, when we train an in-painting model on such data, the model tends to follow to the original clothing shape as shown in this figure. So, for example, the target person already wears the black long pants, and when we want to try on the short skirt, then existing model generates some mixed style, long pants with some this texture, short skirt texture. So our method is designed to resolve such two conflicts. So first, to address the text conflict, we'll label attributes from both the reference and the target image, then compose them into a final prompt. And to address the spatial conflict, we introduce a coarse mask into both training and inference. So let me introduce one by one. Because the final output must not retain the original garment details, it is crucial to separate target and reference information when describing text in reference-based generation. And for fast text description, we use an LLM to label attributes. And we first set the representative attributes to show the outfit style or body shape. And the labeled attributes are then routed via a fixed template into a main prompt and a reference prompt for the reference unit, and the main prompt to main unit. So the main unit contains all selective information for the final outputs, and the reference prompt contains only the reference. In this case, the top clothing. Next, our masking strategy for the spatial conflict, starting with inference. So suppose we want to control untucked styling. We first run inference with the text prompt and a coarse mask that removes almost prior garment information. From the generated images, we extract a garment mask only. This is broader and reflects the prompt semantics. If the prompt asks for fully tucked, the resulting mask become narrower accordingly. But in this case, we input the untucked, so the t-shirt shows the untucked style. And we then union this prompt aware mask, this, and with the fine mask that still contains remnants of the original clothing. Using this combined mask as input, we generate the final image like this. So this removes the original garment while preserving the target person's region. And earlier masks like the fine mask tend to keep the original clothing shape, as I mentioned before. So we train the both coarse mask and fine mask in detail. Between the coarse bounding box like version and the fine mask, we randomly dilate to build input mask for train like this. So the actual input is dilated mask as shown in the figure. Yeah, and this is all brief introduction of our method and experiments. So when compared with baselines, our method better preserve the reference clothing and does not follow the original clothing silhouette like this, and even for complex outfits with multiple layers. So for long dress, for example, baselines often revert to short skirt shape as shown in before, but because our model has greater freedom, mask freedom, metrics that require near pixel correspondence like SSIM can be lower than using the fine mask alone. However, in qualitative research, we can see more natural and high realistic results as shown in the figure. And so, in some ablation study, so a knife description leads to conflicts between old and new clothing, and to verbose irrelevant text, which produces artifacts and thus higher FID and KID like this. And if you remove PMG, so PMG means prompt aware mask generation. If we remove PMG and use only a coarse mask, the model tends to generate extra region. For instance, in this case, some hallucinating belt, so this degrading SSIM and LPIPS. As a result, our full method shows best results in all metrics. And our framework also supports diverse styling from the same reference. So tight fit or loose fit, and some roll-up styling. So if the mask is too restrictive, loose fit styles can be difficult. With our prompt aware masking, they become feasible. And finally, we can broaden the application. So we can dress pants or add inner wear and then place on outer coat while preserving the inner layer. As shown in the right, and we can, as shown in the below, so we try to text prompt. So all clothing combination, we can control the outputs, even in multi-layered outfits. Yep. Thank you for attention.